Usually students take 5 to 10 minutes to solve such problems from game theory, but I am going to tell you how to solve it just in 1 minute. So in this video I am going to give you a shortcut trick to solve this game theory. We always try to find out the saddle point for any game theory. If saddle point exists, that is pure strategy game. If saddle point does not exist, it is mixed strategy game. Correct? Let's now check for the saddle point. How do you find out the saddle point first? You add one last row and column, which is nothing but row minima and column maxima. Now let's find out the smallest number in each row. So in first row it is 0, second row it is 1, here minus is there, so minus 5, minus 1, minus 2. Yes, these are the row minimums. Now column maximum, here it is 4, 3, maximum number is 7, here the largest number is 3, here it is 2 and here it is 2. Right? Now you have to find out the maximin and minimax. So what is maximin? Means maximum number from these numbers, which is nothing but this 1. Yes. And what is here minimax? So minimax is nothing but minimum number from these maximum numbers. So what is minimum? 2. You can take this 2 or this 2. So if maximin is equal to minimax, then saddle point exists. Is it? 2 is not equal to 1 means saddle point does not exist, and this is not pure strategy game, this is mixed strategy game. So now you have to apply the other method, which is algebraic method, to solve the mixed strategy game. We have already seen in one video how to solve that. So basically for that method you need this matrix as 2 by 2 matrix only. Is it 2 by 2? No, it is 5 by 6, 5 rows and 6 columns, right? So this matrix is 5 by 6 matrix. I am going to tell you the trick to how to reduce this matrix to 2 by 2 matrix, and then you can use that algebraic method. Okay, so there is something known as principle of dominance. Okay, and by using that principle you are going to reduce this matrix up to 2 by 2. What is that principle? You straightway have to start with rows. Okay, you have to compare the two rows, any two rows, no problem. I'll explain you how this is done. So compare two rows. We'll start with A1. We'll keep comparing A1 with all of these rows one by one, and let's see what we get. So in the beginning, just check. It has to be the equal to is also valid. Okay. So now equal, this is smaller, this is smaller. So you're comparing basically these two numbers. Now A1 and A2 comparison is going on. So equal, this is smaller than 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 this. Means all the elements in A1 are smaller than or equal to A2. Correct? Is this the right expression? Yes. So whichever row is dominating, that row you will keep as it is, and then whichever row has all the smaller values which is getting dominated by that bigger numbers, that row you can cut. Right? So which is getting dominated? This one is getting dominated, right? Because all the numbers are smaller or equal than the next one. So you will cut this row. Yes? Now let's again do for the remaining matrix, same process. Now compare this with this. For equal, this is smaller, but then here minus, so this is not valid here. Now compare A2 with A4. So we'll do it one by one only, right? So after equal, this is smaller, but here it is minus, so forget about it. Now A2 and last is A5. Compare those. Equal, this is smaller, but then this is bigger, this is again. So yes, the comparison of A2 is done with all. Now A3 with the respective lower rows. So equal, this is smaller, but then here this is smaller. So no, A3 and A5 equal, this is smaller, but then here this is smaller. Yeah, so A3 is done. Now A4 and A5 comparison will do. Equal, this is smaller, this is also smaller than this is equal, so yes, we found some relationship between A4 and A5. What is that? Either equal or A5 is smaller than A4. So A5 is smaller than A4. Yes, this is the relation which we established. So whichever is smaller, you need to cut that row. Correct? So what is smaller? A5 is smaller here. So you will cut this row. Okay. So now the remaining matrix is this much. Yes. So always remember, in case of rows, you will keep the maximum row and you will cut the minimum row. But in column, it is exactly opposite. So you will always delete or cut the maximum column. Yes. Why is it so? That everything is logical in maths. Okay. So what's the logic? A is maximizing player, B is minimizing player. Means A always tries to maximize the gain and B always tries to minimize the loss. Yes. And that is why as A is maximizing player, so maximum numbers when you are going row wise, and when you are going column wise, you are going to keep the smaller numbers because B tries to minimize the loss. Now let's go column wise and see. You will compare this B1 with B2. So this is smaller, this is smaller, and this is smaller. Yes, easy. So in this case, what happened? B1 is always greater than, not even equal. B1 is always greater than B2. So whatever, as I mentioned, whatever is greater, you need to delete that when it comes to column. Why? Because B is minimizing player. Yes, so you will keep the minimum values there. Okay, now that is gone. Now compare with this B2 and B3. What is that? So this is minimum, but then this is greater than this. So leave it. B2 and B4 equal. This is minimum, this is minimum. Yes. So when you compare these two, you get some relationship, and that is what? B2 is greater than or equal to B4. B2 is greater than or equal to B4. Correct? Now whatever is greater, you need to cut that. So you have cut the B2 also. Yes. Now compare this B3 with B4. So this is minimum, but then here it is opposite way. So forget it. B3 and B5. This is minimum, but this is maximum, greater than 1. Yeah. B3 and B6. This is lower, but then 7 is maximum. So forget about that. Now B4 and further comparisons. So now compare B4 and B5. So this is smaller, but here it is B4 wala smaller. Yeah. Forget about it. So B4 and B6 now. So see now, this is 2 is smaller here, but here minus 5. So no any luck with this. Now let's take B4, so now let's take B5 and B6. Yeah. So B5 and B6 comparison. So 2 equal. This is smaller, equal and equal. Yes, we got some relationship. What is that relationship? B5 is always going to be lesser or equal to. B5 is going to be lesser than or equal to B6. Means B6 is on the higher side. Yes. Whatever is higher, cut it because it's column wise. Yeah. Now see, this is the remaining matrix. Now again try to go row wise and column wise and see if you get any relationship. So I am going row wise now. So this is smaller than this, but here it is minus. So leave it. Now compare between these two, 1 and this, 4, this and this. So this is smaller, but then here it is minus. Forget it. Now compare these two. So 4 is smaller, but here minus 5 is smaller. So row wise, no luck. Let's quickly check column wise again. So this is 1 and 3. So this is minimum, but here it is minimum. So no. Between this and this, so 1 is smaller, but then 7 is larger. Now the only remaining comparison is this B4 and B5. So this is smaller, but here minus 5 is smaller. So now there is no any relationship, that specific or concrete relationship does not exist. But did you get the 2 by 2 matrix yet? No. This is still 3 by 3, right? And we need 2 by 2 matrix only to start with the algebraic method for game theory. Now how do you do the conversion in 2 by 2? So now next step is very easy. You take the average of any two rows or columns and try to compare it with the remaining one. Okay, and see if you find any relationship. Now let's see the average of B3 and B4 and let's compare that with B5. Okay, let's do that. So 1 plus 3 is 4. 4 by 2 is 2. Yes, here 7 minus 5 divided by 2 means 2 by 2 is 1. And here 4 minus 1 is 3 divided by 2 means 1.5. Yes, you got some relationship now, right? Between these two. Compare this average with B5 now. See, equal, and this is smaller, right? Now in case of column, what do you always try to do? You cancel or you cut the maximum row, maximum column. Yes. So this is the maximum column, right? And therefore you will cut this B5 now. Okay. Now one very important point I am going to tell you here. If this was the opposite case, right? Means if this was some value greater than 2, right? So in that case, what would you do? Would you cancel these two? No. No. Always remember that is a big no. Because that's just the average, right? Those are not really independent figures. If something like this happens, you just try the other combination then. Okay. So now this is done. Now see, it is, if you take the column wise look, it is already there are 2 columns only. Now I have to do something with the rows. Correct? So let's start the same process, taking average with rows. So now if I take the average of these two, A2 and A3, how much it comes? I'm sorry. So this average comes as 7 plus 1 divided by 2. So 8 by 2 is 4. Yes. Now the next average here is 3 minus 5. Okay. Divided by 2. Minus 2 divided by 2 is again 1. Yeah. So now see here. You got everything exactly same. equal to is also a valid criteria, right? We have already seen equal to is also valid. Okay, now in this case you tell me, would you cut these two or this? As I already mentioned, you are not allowed to touch the rows or columns for which you are taken the average, right? That is just for calculation purpose. So whatever is remaining, you will cut that here, correct? The solution is valid, those are equal. So ideally in the equal case you can cut any, but here it is average, that is not an independent row. You understand my point? That's why you cut this, and now the remaining matrix is this much only. Yes, finally you got the 2 by 2 matrix. So you can start solving this by your algebraic method. Okay, now what is that method? So to show you how algebraic method works, I would just copy this matrix here, right? So what is that? 1, 3, 1, 3, 7 minus 5. See, this part we have already seen in the previous video also, but then I am taking this example which covers everything. Correct? Pure strategy, mixed strategy, just of 2 by 2, and if some bigger matrix, the dominance rule also, right? So first thing you do is you find out the oddments. Yes, you find out the oddments. What are the oddments? So oddment is nothing but the difference between the two numbers. Always subtract smaller number from the bigger number. Yes, the sequence does not matter. Bigger number is 3, so 3 minus 1 is 2. But you are not going to write down this 2 here, you will write it diagonally. Yes, that's the basic rule. Okay, now for this 7 minus 5. Yes, I told you the subtraction we are doing, right? So 7 minus this minus 5. So ultimately it becomes 7 plus 5. So that is 12. You will write down diagonally. Now for this 7 minus 1 is 6. So you will write it here. Now here 3 minus 5. Yes, the same way. So it is 3 plus 5 basically. So that becomes 8. Oddments are done. You will add one more row and column for probability. Yes, for probability. Correct? You this 12 as it is divided by the total of those oddments. So what is the total? 14. Yes, the probability here is 2 by 14. Now here probability is this oddment divided by total is 14. Here again 6 divided by 14. Easy? If you reduce this further, how much it gives you? 2 6s are 2 7s are, and here 2 1s are 2 7s are. Yes? If you reduce this further, you get 2 4s are 2 7s are. Here 2 3s are 2 7s are. Correct? Easy? So these are the probabilities, respective probabilities of player A and player B, who are using which strategies? A2 here, A3 here, and column wise if you see B3 and B4. Yes? So they are going to use these strategies in these probabilities, right? How do you write down this whole thing? So see now, the strategies for A and strategies for B. Yes. So how many strategies? A has 5 strategies, right? So comma, 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 comma. These are the 5 numbers, and B had 6 strategies. Comma, comma, 3, 4, 5 and 6. Yes. So what are the strategies which are opted by A, A2 and A3? But then in what proportion? 6 by 7 and 1 by 7. So A2 is 6 by 7, A3 is 1 by 7, and other strategies are 0. So he is not going to use any other strategy, and he will just use these two strategies in this proportion or in this probability. Okay, now what about B? The same way, B is using B3 and B4. So all others are 0. Yes. What are the B3 and B4 probabilities? 4 by 7 and 3 by 7. So this is 4 by 7, this is 3 by 7. Yes. So up to this it is clear. One more important point you need to always find out in the game theory is value of the game. How do you find it out? Value of the game. In case of pure strategy game, it is very easy. Just whatever the saddle point you got, that is your value of the game. Yes. In mixed strategy, you can consider any row or column and its corresponding oddments. Yes. So let's assume that I am taking this first column into consideration and then its respective oddment. So what do? 1 into 12 plus 7 into 2 divided by total of the oddments. Easy? Yes. There are many, again I repeat, there are many formulas in this game theory, but I am not going to use any of the formulas which will ease your calculations. Yes, from the exam point of view. So this 1 into 12 is 12 plus this 7 into 2 is 14 divided by total of this oddment is 14. So what is that? 26 divided by 14. If you simplify this, how much you get? 13 divided by 7. Yes. So this is the value of game. Now there are multiple ways to find out the value of game. instead of considering the first column, you can consider the second column and corresponding oddments, the same value you are going to get. Even if you consider the row wise, still you will get the same answer. Means 8 to this row and corresponding oddments. Means 1 into 8 plus 3 into 6 divided by this total 14. Yeah, still you will get the same answer. Okay, so I hope you like this video, and I have tried to cover maximum concepts in this video. So if you like this video, please like, share and subscribe to my channel, and keep watching, keep studying. Send it to your friends who really need to watch this and whose exam is approaching. Yeah, see you in the next video. Bye bye.